So we start with what I'm going to call a level 1 problem. So a level 1 projectile. Now, your book, I'm going to be 100% honest with you. A level 1 has an object that simply rolls off a table. The reason I call this a level 1 is because this object isn't launched at any angle. When we consider what we talked about yesterday for motion, when you consider this projectile, it's got 2 parts to its motion. And I have talked about this. I put this on the board. I'll put this down a lot because this is what I consider to be a framework for how to solve these. I'm going to split these problems up into vertical and horizontal. And the reason I think it should be obvious after our discussion yesterday, only one of these is experiencing an acceleration. And it's this one. The vertical part of the object's motion experiences an acceleration. The horizontal doesn't. So, for those of you struggling to see, in the back I can see that. That's what I've drawn. So the vertical has the 5 motion variables: displacement, initial velocity, final velocity, acceleration, and time. The horizontal, there's no acceleration. So I just have the range, which is the horizontal displacement, the velocity, and the time. As indicated yesterday, these 2 things are the same. The time that it takes to fall to the ground is the time that it uses to go sideways. Generally, all projectile problems are about time, about figuring out what time the event occurs. So when we're doing these, that's really what I'm trying to get you to look for. This one's no different. Let's assume this is the tabletop. So this is about 1 meter tall. And let's say I roll it at 2 meters per second towards the edge of the tabletop. And I want to know, where does it strike the ground? Now again, they're never going to ask this question on the exam, I don't think. I think they're going to jazz it up some, but I do want you to remember that we're assuming there's no acceleration horizontally. But if it was really windy in the classroom, you realize it would affect this answer, right? So if the wind were blowing this way, we know it's probably not going to land there. It's probably going to land over here someplace. Fair enough? All right, so let's just keep that in mind, but let's see how this is done mathematically. First, I want to try and acquire all the given information. Believe it or not, everything I need to solve the problem has been given already. For example, I know that the object's going to fall downwards 1 meter. So in delta y, I put 1 meter. I know that at the instant it leaves the table, it's not moving up or down because it's going across the table. So at that instant, this point right here where it leaves the table, its vertical velocity is 0. By the way, that's the simplification. That's what makes this problem easy to solve, is that it doesn't have a vertical velocity. Now when it leaves the table, I know gravity is going to be pulling it down 10 meters per second squared. And that's all I have when it comes to the vertical part of the problem. But this 2 meters per second, that's how fast it's moving horizontally. So I'll put that 2 meters per second over here. Now, like I said, I'm trying to figure out the range. These 5 motion variables suggest the motion equations. Since there's no acceleration, this side is always found by relating the horizontal velocity, the time, and the range. Right? This is what you get when the acceleration is 0. You get displacement equals velocity times time. We've talked about that. So now the actual question. How do we figure out where it lands? And this part's critical. The time it takes to go up and down is equal to the time it takes to go sideways. In these problems, we're generally trying to figure out the time on one side and use it on the other, which means I either need 3 pieces of vertical information or 2 pieces of horizontal. In the case of this problem, I have 3 pieces of vertical information. I'm going to find a relationship that allows me to figure out the time. Before I do so, though, I need to remember a bunch of these are vectors. And when it comes to vectors, I've got to make sure I'm keeping track of what's positive and what's negative. I'm going to make upwards positive and to the right positive. So you'll see me draw one of these on every problem so that I'm at least identifying what I want to call positive. So when I go down this list, the displacement in the y direction is negative. It falls below where I started. Remember, if you want, you can write this as y final minus y initial. And y initial is 1, y final is 0. It's landing on the ground. 0 I don't have to worry about, but the acceleration, definitely negative. Gravity pulls it downwards. So, looking at this, I note right away I can find time on the left side. I have 3 pieces of information. I'm going to find a relationship that allows me to figure out the time. I look over there on the board, try to find which motion equation is going to work. I see 0. The time it takes to fall is equal to the square root of 2h over g. This is worth memorizing. And I'm going to prove that's true, but I want you to keep in mind that you could use this as a shortcut. It'll make things go much faster. But let's just make sure you see it, because in this problem, I'm going to use delta y equals 1/2 a t squared plus vy initial times t. Notice this equation isn't that one on the board. I know they're different, but do you see how they're the same? That one's got x's in it, and this one has y's in it, but they mean the same thing. I really didn't think I had to explain that to you guys, but I am getting back to this. We were not given, or we were told this is 0. So if I'm trying to find the time, do you see that all I really have to work with is this? Do you guys see that okay? And moreover, do you see that t would be equal to 2 delta y over a and then take the square root? Can you work that far in your notes real fast and see that's got to be true? You guys are sharp kids. You know algebra. You know that I can multiply both sides by 2, that's 2 delta y. Divide both sides by a, that's 2 delta y over a. And then take the square root of both sides. Thus, square root of 2h over g. You see the similarity there? If not, then I'm not talking to you. Do it the long way every time. But for you guys who see the shortcut, how many minutes I can save you on the exam? Yeah, about 1 to 5 over the course of the exam. That can be between 2 and 4 extra questions. It's worth considering. Shortcuts mean something on this exam. So I'm just going to say that the time is equal to the square root of 2 times -1 over -10. Which is, let's see, that's 2/10 or 0.2, the square root of 0.2. Now, you got to figure out what the square root of 0.2 is. That's where your calculator probably comes in handy. But square roots of decimals work like the opposite of square root of regular numbers. our number's going to get bigger when we take the square root. So I would try and think of a number that when you square it gets you 20. Can you think of a number that when you square it gets you 20? What number would get you close to 20 when you square it? Yeah, what's 4 squared? What's 5 squared? So I'm thinking that my answer is going to be either 0.4 or 0.5. It's got to be between those two. And of course, somebody has their calculator and already knows what it is. What is it? 0.4 what? 0.4 what? I'm really asking.
4.
Thank you. Oh, 4. Got it. Yes, and keep in mind, it takes about half a second for something to fall off your desk. That's almost always going to be true. Keep that in mind for your lab coming up and your test. I'm going to be mounting this thing to my desk. If you find out it takes 1/10 of a second to reach the ground, you blew it. Because it takes at least half a second for something to fall from my desk to the ground. So the time is going to always be around half a second or a little more if I shoot it at an angle. So just keep your math in mind, real numbers. Not so hard now. That means this is 0.44 and this is 0.44. The time gets written in both places because it takes the same time to fall to the ground as it does to move sideways. Wow, that's pretty messy, isn't it? If you were looking at your notes right now and all you had was that, you would have no idea where the problem began. Wouldn't you agree? You might want to make sure you have maybe some stuff in there that says that the first thing you do maybe is to sketch out a little picture. Second thing you do, maybe draw this chart. Third thing you should do maybe is flesh out the chart with the numbers you were given. The fourth thing you should do is find a way to solve for time. The fifth thing you should do is apply the time to both sides. And now, get yourself an answer. R equals 2 times 0.44, which I'm thinking is about 0.88. So this object lands 0.88 meters away from the edge of the table. That's the answer. Even in this question. You might not think so, but if we get all this away for a minute, just consider that, make it nice and small. What was my launch angle? 0 degrees. 0 degrees was the launch angle. What was my launch velocity? 2 meters per second. So Vy initial was 2 sine 0 degrees. And Vx was 2 cosine 0 degrees. And the cosine of 0 is 1, so this was 2. And the sine of 0 was 0, so the vertical velocity was 0. It was there before, it was hiding, but the launch angle was 0 degrees, so it worked out to give us the right values, this being 0 and this being 2. Okay? So it was there the whole time. But this is a really lame projectile if I launch it horizontally from the ground, because then it's just going to roll, not a projectile, right? So in order to make it a projectile, I'm going to launch my projectile at 40 degrees and a velocity of 5 meters per second. Suggesting that as anything, you guys have all thrown something in your life, or at least seen it done. The object's going to go in some kind of curved path until it reaches the ground. Again, meaning you're going to have some range to deal with. Now, just like what you saw before, this is a projectile problem. Do you see it meets the rules of a projectile? It's moving in 2 dimensions, but it's going to accelerate in only 1. Gravity's still going to accelerate this and bring this back to the ground. The difference This object's going to start with a horizontal velocity, right? A velocity that is sideways, and a vertical velocity. We talked about this yesterday and the day before. It's going to have two velocities. Thus, we learned some trig, so we can figure out what the two velocities are. In fact, that green arrow, I'm going to draw that green arrow right here to form a right triangle. Now, for those of you straining to see, big enough? The green arrow and the yellow arrow represent something called components. They are two right-angle vectors that make up a third vector. That's what components are. Two right-angle vectors that make up a third vector. Here's the right angle. This green arrow represents the initial y velocity. That's the y velocity it will have at launch. The yellow arrow represents the horizontal velocity. And I hope you guys notice this is a triangle. It fits all the rules of our right triangles. I have an angle and I have the hypotenuse. So the sine of 40 is going to be opposite v, y initial, over hypotenuse, 5. Right, the definition of sine is opposite over hypotenuse. You guys following that okay? So the cosine of 40 degrees is going to be the adjacent, Vx, over the hypotenuse, 5. And now, if I want, and I do, Vy initial is 5 sine 40. And Vx is 5 cosine 40. Now you guys are shrewd and sharp individuals. So back to this ungodly mess. Back to being there. There we go. So now that we know that, got it in our head, let's consider the second part of that, which is put together my little vertical and horizontal chart. R, Vx, T, delta y, Vy initial, Vy, A, and T. Now I know some of you are a little nervous because I got the sines and cosines going on, but 5 sine 40 degrees is just a number, something less than 5. And 5 cosine 40 degrees is just a number, something less than 5. So if you would please, make sure your calculators are in degrees. Fire those bad boys up and tell me what we're looking at here. Because I'm thinking like the vertical one, probably like 2.6 or 2.5. Who's got me with them calculators? You got what? 3.2? I'll take your 3.2. I'm all right being wrong. Somebody else get 3.2? All right, let's figure out the horizontal one. 5 cosine 40. 3.8. All right, so it's a little bit faster horizontally than it is vertically. That's it. That's the trig part. Get the trig part down. You guys should be able to figure it out. Now I know how fast it's moving up and down. And now I know how fast it's moving sideways. But like I told you at the beginning of this, the type 2 problem was going to make some of it harder. You just saw what was harder. It's going to make some of it easier. The ball lands at the same height it was launched. Delta y is 0. Gotta love that. Anytime you can get a 0, take it. Acceleration is going to be 10. We now know everything that's been given to us. Let's go ahead and consider direction. You guys okay with up positive and to the right positive? Fantastic. That means positive, positive, and negative. I need the time. I'm gonna tell you, you're gonna use this same thing an awful lot. Now, I would at this point say, I don't think I really need to do this with you guys. You guys can finish it up. But my experience is that some of you won't. So I will continue, mostly because I fear that you won't do it on your own. I also have great fear that you guys don't know what to do here, that you're just going to divide by t, and that's actually bad math. And I want you to do good math. So you should factor out a t. And you should set both of these equal to 0 so that you get two answers. T equals 0 and negative 5t plus 3.2 equals 0, or t equals 3.2 divided by 5, which is like 0.61? 0.64. 0.64, right? That's right. I know my times tables. 0.64. Which of these two times is correct? Actually, they both are. Remember, we asked math to tell us when the object was on the ground. When was it on the ground? At 0 and 0.64. It started on the ground, it ended on the ground. Math gives you back what you tell it, and we told it to tell us when the displacement was 0. That's why we have both answers. But I think we're only considering where it lands. Write my times in both places so I can keep track, but I know this is what's left. The range equals 3.8 times 0.64. I don't know, 2.4 meters? I'm guessing. Yes? I know my math tables. I can do multiplication. I'm so proud. Whoa. Let's hit a pause. This is just all like a mess. There's so many things here. But we have a place to start, don't we? You know, I'm going to start by saying, look, I've got my launch velocity in the x direction and in the y direction. Need to be remembering, I got to use my trig. So I'm probably looking at a Vx here and a Vy initial here. Luckily, we just did this, but I'm still going to write out 5 cosine 40 and 5 sine 40 because repetition helps. I'm going to go ahead and start up my chart here. I'm going to write vertical, horizontal on it. I'm going to put R, Vx, and T. And I'm going to put delta Y, Vy initial, Vy, A, and T. God, that's a lot of stuff. Just so many stuffs and things and places to screw up. I'm going to look at this problem and start at the very top left-hand corner and start writing down what I know. I know that the object has to fall 1 meter. It lands on the ground. Right? I'm thinking, boink. Somewhere over there, maybe, boink. I really don't know what it looks like. But this big arrow is in the way, so I'm just going to keep it out of the way. I know that the initial y velocity will be 5 sine 40, which you guys all told me was 3 point something. Thank you. And I still got gravity in there. And don't forget, if you're doing mastering, and you will be, it's 9.8. And I know it moves horizontally 3.6. 8, that's what I said, 3.8. Yeah, meters per second. And now I'm going to say, okay, upwards is positive and to the right is positive. We'll go in there and make sure my signs all are in agreement. And now I'm at that point. I need how long it's in the air. Only one way to do that. Oh, and this is going to be painful. You got a picture in front of you right now, don't you? Good, so I can go over here. All right, going back here. 0.87. 0.87. This is the answer here. 3.8 times 0.87. It's a mess, but this is it. This is where it lands. This is where you put the target. Come on, hit me with it. 3.3 meters. That's the answer. All right, folks, you have seen it all. Now, say, all right, delta y equals 1/2 a t squared plus vy initial times t. And that's going to be -1 equals 1/2 times -10 t squared plus 3.2 times t. And now does yesterday make more sense? Do you see why we had to have yesterday before today? And why we had to have triangles 2 days ago before today? And there's nothing nice about this. These numbers will never be convenient because they're always going to be coming from something that was sine or cosine, right? So they're always going to be a bit of a mess. So you're just going to have to get used to that. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And I get it. There is absolutely nothing pleasant about that. But is it beyond your abilities? But again, do you see all the places to make mistakes? Gosh, just so many. Just so many. So you got to grab that calculator and write it like there's no tomorrow. But if you're me, and I'd like you to be me for just a minute, which means stop pushing them buttons. But again, I'm expecting to be about 0.8 seconds. 0.86, 0.87, 0.87, good for all of you? And if you didn't write that down fast enough, bummer. I'm going to come back to it, but write faster. Please just think about this for just a moment. I'm going to draw this nice and big for us. If we are ever given a launch velocity and an angle, do you realize that we're always going to have the same triangle to describe the vectors here? Right? Do you see it's always going to be a triangle like that? The angle might be different. The launch velocity might be different, but there's always going to be some launch velocity and some angle. If you're really paying attention to me and you really know your stuff, you realize this will always be the opposite side. And this will always be the adjacent side. Which means my opposite side is always the initial y velocity. If they give me the angle relative to the horizontal, that will always be true. Which means sine theta will always be the initial y velocity over the launch velocity. Which means, if you want to memorize something, that might be worth it. The vertical velocity is always a part of the launch velocity. It's the sine portion. And look, I really don't want to do this, so I'm just going to write it because I think you guys are smart enough to realize that the very next step here is to see that the horizontal one's the adjacent side. That's Vx. If you want to save a little time, just keep those in mind. Now, I think you should be able to figure out from the triangle every time. I have no trouble drawing the triangle every time and doing this, but look, some of you need some help. This is what it's going to be probably every time. Unless they give us this angle, there'd be no reason. Nobody says that you aim like that. You don't aim from the wall in some direction. That doesn't make any sense. I will say that this